Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and related topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon and Buy Me a Coffee. Links in the description box below. Today we're going to cover Strength of Materials in 6. The topic of this tutorial is a mixed bag of possible exam questions, round 1, question 1. The formulas used are included in the video after the question. The question is also posted in the description box below. Let's get straight into it. Okay, first off, we have a cable that is trussed up between 2 points. Let's read the question and we can find out how the question goes. So, a steel core aluminium conductor with a length of 150 meters has a weight of 60 newtons per meter and is supported between 2 supports. The turning point of the cable is 62 meters from the shortest support, measured along the length of the cable. The total cross-sectional area of the cable is 500 millimeters squared and the steel core area is 50 millimeters squared. The maximum allowable stress in the steel and aluminium is 42 megapascals and 14 megapascals respectively. Calculate the maximum tension allowed in the cable, the difference in height between the 2 supports, the horizontal distance of the highest support from the turning point, the horizontal distance from the longest support where the tension is 7,800 newtons. Okay, so what we can determine from this is that our turning point it'll be something like this. Our cable will be something like this, and our turning point is here. Right, so between there and there is 62 meters. 62 meters. Now this is Y1, Y2. Now what we'll need next is from there to there. So the height. So we'll need H. We will need, so this point here, from there up until there, we'll need that. We will need X2, X3. Right, that's what we'll need. Now also, we're going to draw our cable with its cross-sectional area, because that is also important to our calculations. Alright. There's our steel core. So our area of steel is equal to 50 millimeters squared. The area of aluminium is 450 millimeters squared, and the total area total is 500 millimeters squared. Okay, now let's get our information. Our length is 150. That's the length of the cable from there all the way around to there. Our weight of the cable is 60 newtons per meter. That's quite a heavy cable. And L1 is equal to 62 meters. Now the next thing is we've got our areas. Now we just need our stresses. Stress for aluminium, stress for steel is 42 times 10 to the 6, and stress for aluminium is 14 times 10 to the 6. Pascals. Okay, now what we will need for future calculations is this length here, from the turning point to there. So that'll be L2 is equal to L2 equals 150 minus 62, which gives us 88 meters. Okay, now what we will do here is say 88. What we got here is 88 meters. There's 88 meters there. Now, what we are going to do is work out our total tension. So, our F total is equal to the stress in steel times the area in steel plus the stress in aluminium times the area in aluminium. So this will equal 42 times 50 plus 14 times 450. Which equals 8400 newtons. Okay, so Ft equals 8400 newtons. This will be important in the next calculation, so please make sure you get the calculation correct. Now, what we're going to do is take Y2. It's going to equal this is Y1 and that is Y2. So, Ft over W. Okay, so Y2 is equal to 8400 all over 60. This W is your weight. So this equals 140 meters. So Y2 equals 140 meters. Now how this works is newtons, and that is newtons per meter. So how this will work, the reason I've got meters here is because newtons and newtons cancel each other out. And when you have a division, it comes to the top. Because this is all, it's newtons over m. Right, so what happens is, the m comes to the top. And you're left with that, and a 2, and then it becomes that. Right, so y2 equals 140. Now we're going for YO. That is from the turning point down to the ground. YO. Now, YO equals the root of Y2 squared minus L2 squared, which equals the root of 140 squared minus 88 squared. Now this will be 108,885 meters. So YO 108,885 meters. 108,885. Right, so now we need Y1. This was the root of YO squared plus L1 squared. So this will be Y1 equals the root of YO 108,885 squared plus 62 squared. And that gives us an answer of 125,2999 meters. Now, for the sake of easier calculations, we are going to make this 125,3 for easier calculations. So 125,3 meters. So Y1 equals 125,3 meters. Okay, 125,3 equals. Now, all we have to do is they want the difference in height. So, Y2 minus Y1 is H. So H equals Y2 minus Y1, which equals 140 minus 125,3 equals 14,7 meters is H. So equals 14,7. Now, our other calculations are all to do, all our other calculations are to do with X and X. We want our X's now. We want X2 and X3. So, for X2, what we're going to do is we want the horizontal distance of the highest support from the turning point. So, that's X2. So we will want, so actually, that's actually is x2. We want x2. So, what we're going to do now is say x2 equals yo ln times y2 my plus L plus L2 over yo. That is our formula. So, what we need to do is 108, 885 ln times 140 plus 88 all over 108, 885. And that equals x2. Now x2 equals 80, 472 meters. x2 equals 80, 472 meters. Alright. Now, as we look to question 3, we need to find y3. So y3 will be the height. So what we need to find first is our, so y3 equals f3 over w. So this is the same formula as we used right in the beginning with the second question to get our y2. It's the same formula, just used in a different way. It's exactly the same. So 7800 all over 60, which is 130 meters. So y3. So from the point of 7,800 newtons, which is, I would put it round about there. The point from there to there is y3 equals 130. It's right there. So, now we've got that, we can calculate L3, because we need that. So, this is the root of yo squared minus plus y3 squared plus yo squared. Actually, it's minus. Sorry, my mistake, it's minus. So, this will equal, right, the root of 130 squared minus 108,885 squared, which is equal to 71,021 meters. L3 is equal to 71,021 meters, and y3 is equal to 130. So, now all we have to do is plug in y3 into our formula of x3 equals yo ln y3 plus L3 all over yo. So all we have to do now, 108,885 lim times 113 plus 71,021 all over 108,885, which equals 66,759. This is meters. This is from the turning point. So this is from the turning point. So we'll get from there to there. Now we need to add the two together. So x equals x2 minus x3, which equals 18, 472 minus 66,759 equals, and that is 13,713 meters. So that is how far this x is. That is how far that is from each other. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you'd like me to cover in upcoming videos. Now, please, the formulas that I have used in this whole diagram and some that I've done for you. These formulas do not appear on your formula sheet, and they do not appear in most textbooks. So please, you must learn these. I've put them in a slide before the video, and I've put it after the video as well. But please, review all your formulas. Everything is secondary to your formulas. The values can change, but your formulas will always stay the same. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.